We now turn to the second type of reaction that we'll study today. We turn to acid-base reactions. And remember, we're looking at Bronsted-Lowry acid bases. And in a Bronsted-Lowry acid base, here is the acid. It has the H+. That's the acid. And it will react with the base. And they will react. And in this clip, I'll just tell you two general trends which control the favorability of acid-base reactions. Two trends. The first one we'll talk about is what I call cascades. So we're going to group similar, a series that's related to each other. The first example we'll take a look at is water. And if I remove an H+ from water, I get OH-. And if I remove a second H+ from water, I get O2-. And of these three, which would be the strongest base? So which of these would react most with H+? And put in chat what you think. And the one that's going to react most with H+ is the one which has the greatest minus charge, because minus attracts positive charge. So O2- is the strongest base. And we can look at another cascade. A second important cascade is H2CO3. Take away an H+, it's HCO3-. Which one? And take away another H+, it's CO3-2-. And which of these three is the strongest base? And the answer again will be the one with the greatest. Put it in chat. Which was going to react with H+ the most? And the answer is it's going to be the CO2-2- because it has the greatest negative charge. So it's the strongest base. So in a cascade, and the cascade is we take a compound and we successfully remove H+, we get stronger and stronger bases. And in the same way, we can say which of these three, and they have names. I'll give you the names. This is carbonic acid. The name will give it away. Carbonic acid. This is bicarbonate. And this is carbonate. Which of the three, carbonic acid, bicarbonate, or carbonate, is the strongest acid? And remember that each time we lose an H+, it's got a bigger and bigger residual minus charge. So carbonic acid, the one with the most H+, the least amount of those minus charges, carbonic acid is the strongest acid. So the strongest acid is always going to be the first element of the first compound in the cascade, and the strongest base will always be the last element. So that's the first set of rule, the rule that you want to know. And then the second rule, the second trend that we're going to go through are oxoacids. And oxoacid is these are species that we've actually learned in Lewis structures. And oxoacid, these are going to be central. These are going to be systems like this. And I'll draw quite a few of them. Cl, OH, OH, HClO4, 3+. Here I'll draw sulfuric acid. With a 2+. I'll draw one more, nitric acid. and sulfuric acid, perchloric acid, and nitric acid. These are all very strong acids. And then I'll draw a couple of not so strong acids right here. NOOOH. This is nitrous acid. It's not nearly as strong. Carbonic acid is really not strong. And so these are strong, and these are weaker acids. And there's a kind of thinking that chemists do, it's very much related to organic chemistry, where you start rationalizing after the fact what makes these acids strong. What do the top three have in common that the bottom two do not? And to my eyes, the big difference is that the top three, the strong acids, all have these plus charges on that center atom. And what, phenomenologically, here's the fancy word, phenomenologically means you look at the facts and you come up with an explanation. Phenomenologically, what do we think having a plus charge would have? And I'm no great expert on this, actually. This is a kind of a way organic chemists think. I'm not an organic chemist. But that plus charge is going to suck some of the electron density in the bond downwards. And that means that this oxygen here will not have as much electron density as it wants. And therefore, it will suck some of its density over towards it because it needs to get it back to where it needed. This is just sort of phenomenological meaning. And so then this is going to be more H plus like. More H plus like. And it turns out, if you look at a lot of facts, this turns out to be correct. The greater the center atom's plus charge, the stronger the acid is. And one way that you can characterize it is you just count the number of O's that are not connected to any, just the central atom. So there are 3 here, 3 O's that are not connected, 2 here, 2 here. But in these weaker acids, there's just 1. And it turns out the number of unconnected O's is connected to the charge in the center atom. And in oxo acids, the more of those O's without H's lead to a greater positive charge, and that's how you can figure out what a strong acid is. And so we have then 2 trends. Let's go through it. The oxo acids, the greater perchloric acid, sulfuric acid, nitric acid are stronger acids. And then in the cascades, the more we remove H pluses, the more we remove H pluses, the more there's a minus charge. O2 minus has a great negative charge. CO3 2 minus has a great minus charge, and therefore they are the strongest bases, and at the other end of the cascade are the strongest acids among the cascade.